In this lecture, we are going to discuss preparation of alcohols. Alcohols can be prepared from alkenes, number two, alkyl halides, and number three, carbonyl compounds. Alkenes, alkyl halides, and the carbonyl compounds. Aldehydes are ketones. Now, from alkenes, it can be prepared by hydration, and by hydroboration. From alkyl halides, it is prepared by nucleophilic. It is from alkyl halides, it is prepared by nucleophilic substitution reactions. Nucleophilic substitution. From carbonyl compounds, alcohols are prepared by nucleophilic addition reaction and by reduction. First, you have to remember these basic things. Alcohols can be prepared from alkenes. Alkenes are the compounds containing CC double bond, alkenes, and from alkenes by hydration, and from alkenes by hydroboration, and secondly, it is prepared from alkyl halides. Alkyl halides is RX, alkyl halides by nucleophilic substitution, and thirdly, from aldehydes or ketones. Aldehydes or ketones by nucleophilic addition or by reduction. And before that, you should understand what is the alcoholic functional group. Alcoholic functional group or OH. OH is the functional group of alcohol. I have already told you that oxygen is sp3 hybridized in water and in alcohol. So sp3 hybridized oxygen is having 4 hybridized orbitals, sp3 hybridized orbitals, in which 2 orbitals have lone pairs of electrons. Lone pairs of electrons are the pairs of electrons which are not involved in the bond formation. And the other 2 hybridized orbitals, one is combining with the R group, and the other one is combining with hydrogen. So ROH, where the bond angle is 108.9 degree, the bond angle, 108.9 degree. It is because of the lone pair bond pair interaction, the bond is bent. The bond is bent. So this you should understand, this is the structure of the functional group of the alcohol. So oxygen is sp3 hybridized, and sp3 hybridized orbitals, there are 4, and these 4 are projecting towards the corners of a tetrahedron, and it is tetrahedral in shape, but the shape of the molecule is bent. The geometry is tetrahedral. So the two sp3 hybridized orbitals are having two lone pairs, and the other two are involved in the bond formation. And because of the bond pair lone pair interaction, the OH and the RO bonds are bent. So the bond angle is 108.9 degree. Now we go to the preparation of alcohols from alkenes. First, alkenes I take R, CH, double bond, CH. R may be anything. A double bond is between this carbon and this carbon, CH2. So 1, 2, 3, 4, 1, 2, 3, 4. So I'm taking alkene. And this alkene, when it reacts with water in the presence of concentrated sulfuric acid, when alkene reacts with water in the presence of concentrated sulfuric acid, the water becomes H plus and OH minus. Now, the addition of H plus ion to the alkene and the addition of OH ion to the alkene, it follows Markovnikov's rule. Markovnikov's rule states that the positive ion, the H plus ion, the proton, will get attached to that carbon which has more number of hydrogen atoms. And the OH minus ion will get attached to the carbon which has less number of hydrogen atoms. Actually, what is happening here is, this is attracting the H plus. This is attracting OH minus. Actually, the electron, the double bond electron is here. Sorry, the double bond electron is here. So it forms CH, CH2, here minus, and here it is plus. So this plus, this OH minus is migrating here, and the H plus is migrating to this carbon. So what is formed is R, CH, OH, CH3. So the H plus is getting added to the carbon containing more number of hydrogen atoms, and the OH minus is getting attached to that carbon which has less number of hydrogen atoms. Therefore, alcohol is formed. This is simply because of the stability of carbocation. So these C plus is stable. When plus is here, it is stable. When the plus is there, it is not that much stable. So this is how alcohol is prepared from alkenes by hydration. And secondly, it is prepared by hydroboration. Hydroboration means, see, alkene is taken. Let us take CH3, CH double bond CH2 is propene. Hydroboration. Hydroboration means plus diborane. Diborane. Diborane is boron, this is diborane. Actually, this boron, this bond angle is 97 degree, whereas this bond angle is 120 degree. And these two hydrogens are bridging hydrogens. Actually, this bond is called banana bond. It's bridging banana bond. Bridging banana bond. So when this reacts with diborane, B2H6, B2H6, what is formed is this compound CH3, CH2, CH2, thrice boron. Thrice boron. So the 6 hydrogens, one hydrogen is getting added here and another hydrogen is getting added here. So six alkenes combined with 3 diboranes, forming 2 such molecules. So this is how it is balanced. Now, when that molecule is CH3, CH2, CH2, thrice boron, when this is reacting with hydrogen peroxide, then alcohol is generated. CH3, CH2, CH2OH, and boric acid is generated. So this is how alcohols are prepared from alkenes.